Good afternoon, Thomas. So due to the nature of the online thing, remember yesterday I told you that we'll just concentrate on the trail sheets for now. So I'll make sure that you have videos for all the trail sheets. And then, though when making these trail sheets, I'll be bringing almost all the concepts that are necessary there. So that when you're physical to physical, it will be easy for us now to just go through some concepts that we feel may be needed. Because we don't know how this thing how long this thing may take. Okay, so we're starting with trail sheet 3 because we started functions. So trail sheet 3. Question 1A. Find the domain of each of the following functions. So here you must using the trail sheet 3. Find the domain for each of the following functions. For A1, the function is f of x is equal to x over 3x minus 1. Remember, we said that for the domain of such a function, our concentration is in the denominator, that the denominator 3x minus 1 should never be equal to 0. So 3x should never be equal to 1. Meaning, if you divide by 3, x should not be equal to 1 over 3. So our domain is any value of x, provided that x is not equal to 1 over 3, but x is a real number. Okay, that's what we call the domain. So don't care about the numerator, for as long as the denominator is not 0, then the function will be defined. 2. So at each point, you must be recalling the types. Remember, this is the one that we called f of x was equal to h of x over g of x. And we emphasize that g of x should not be equal to 0. Okay, then 2, f of x is equal to 5x plus 4 and divide by x squared plus 3x plus 2. Same setup, g, the denominator, must not be equal to 0. Okay, so x squared plus 3x plus 2 should not be equal to 0. So if we solve x squared plus 3x plus 2, you would notice that what we are getting here is x squared plus x plus 2x plus 2 is equal to 0. X plus 1 plus 2, x plus 1 is equal to 0. So x plus 1, x plus 2 is 0. So x is -1, x is -2. So our domain should be x such that x is not equal to -1, x is not equal to -2, but x is any other real number. That is how you get the domain of such a function. Okay. Okay, so that is how you get on the second one. Now we go to the third one. Example 3. You have f of x is equal to root x plus root 4 minus x. Now here, you first get for x, the first one, You know that x must be greater or equal to 0. Whatever is inside the root must be greater or equal to 0. For the second one also, this must be greater or equal to 0, meaning that 4 should be greater or equal to x. In reverse, x should be less or equal to 4. That's the meaning there. So now, if you have a number line, you start from 0. This one requires that you can start from 0 going this far. The other one requires that you start from 4 going this side. So you get where they meet, the intersection. So our domain is going to be, we'll just write it as an interval, where I say the domain is going to be starting from 4 all the way up to positive infinity. That's how you get your domain. So remember that this one is falling on that part where we said f of x is equal to the root of g of x. So now if I have the root of g of x plus the root of h of x, I will get the intersection of the domains of g and h always. So you can see that clearly. Okay, we got the next one. The fourth one. Here we have f of x is equal to root x minus 3, the root of 1 minus x. Now, if x is a cube root, we don't care. We have the cube root of 27 is 3. And the cube root of negative 27 is negative 3. So for cube roots, they always have responses, even if it's a cube root. I mean, cube roots we get for n number, whether negative or positive. But square roots we don't get for n number. So what does it mean? We'll get x greater or equal to 0 for the first one, and x or u for the second one. But remember we say we must get the intersection. So the intersection here will be starting from 0 going to infinity. Because in here we have x greater or equal to 0. In here we also have x greater or equal to 0, except that there we are free. We can use any other number, but you get the common interval. Then we go to 5, where f of x is equal to 1 over the fourth root of 1 minus 3x. Now you treat the fourth root in the same way we treat the square root, because you don't have any sign that can be multiplied 4 times, it still remains negative, no. So if I have negative times negative times negative times negative, automatically we'll get positive. If we have positive times positive times positive times positive, automatically we'll get positive. That's the reason why we demand that the inside must be greater or equal to 0, but the equal to part won't be mentioned now because what we have is in the denominator. So we'll just deal with 1 greater than 3x, divide by 3, divide by 3. So 1 over 3 should be bigger than x. This means that x should be less than 1 over 3. And so our domain is just an interval from negative infinity all the way up to 1 over 3, not included. Because if we include it, we risk having a 0. So don't want to have a 0 in our solution, in our denominator, to avoid 1 over 0, which is undefined. Okay. The fifth one, the sixth one, though it's not so clear, but f of x, what I can see is 3x. Okay, this one is not clear. I can't see anything. Okay. So I'll go to B. Or just here, I give you a task to see if you understand this. Find the domain of 1 f of x is equal to 3x plus 1 over 1 minus 7x, and b f of x is equal to the root of x plus, let me give you the root of x plus -3, and then c, so this is a, c f of x is equal to root 1 minus x plus root x plus 2. So let's see what we get here as your domain, then you should be able to send all these questions. Okay. Question 2, question B of the same one. Sketch the graph of each of the following and evaluate the indicated function values. 1, sketch f of x is equal to, oh, this is the one I couldn't see again. But I think I remember this question in the hard copy. It was 3x plus the modulus of x over, over the modulus of x. Okay, I remember it now. So I also mentioned its domain here. So if you're given this function to sketch, remember B is about sketching. So if you're given this function to sketch, what you do is, we know that by definition, the modulus of x is the same as x for as long as x is positive. It is negative x if x is less than 0. So we also have the same thing, 3x plus x over x. In fact, there was no modulus in the denominator. Yeah. So over x for x greater than 0. So I've removed the equal to because we have x in the domain, in the denominator, which cannot be allowed to be 0. And the same function is going to be 3x minus x over x if x is less than 0. So if we simplify each piece, 3x plus x gives us 4x. So we have 4x over x if x is bigger than 0. We also have 2x over x if x is less than 0. Simplify it further, we'll get 4 if x is greater than 0, and 2 if x is less than 0. Then we can now sketch the function. Okay, so the function is 4 if x is greater than 0. So you start from there, going this side, 4, 0, and start from here, going where? Going this side. That is 2. So the function will be 2 for all the values of x that will be less than 0. For example, -1, -2, -3, to be giving us 2, a constant function. And for 1, 2, 3, to be giving us 4, a constant function. So when a function is constant, what we mean is, if f of x is equal to 3, even if you tell me to evaluate f of 10, I'll get 3. F of 11, I'll get 3. F of -1000, I'll get 3. It will be 3 for everything. That's the meaning of that interpretation there. Okay, so it will still be 3. Anything that I get, it will be getting back to 3. So you must be conversant with the types of functions that you are able to be asked in any assessment. So constant functions are very important, and they're often asked. Okay. So we've done a sketch, and what was to be the domain? The domain of this is any x for as long as x is not equal to 0, but it's a real number. because of that x there, it can be 0. And then if they asked you for the range, we only have 2 and 4. That's all. So we're only getting 2 and 4. And this question was there in your test where they ask you for such a function and then they ask for a range. So that's how you get the range. You only get 2 or 4. If the number is less than 0, you get 2. If the number is bigger than 0, you get 4. The second one. Also on the previous one, they have also asked us to evaluate what is f of -6. So because -6 is less than 0, we'll get 2. They have also asked you for f of 3. So because 3 is bigger than 0, we'll get 4. That's all. Okay. Another one, f of x is equal to x if x is less or equal to 0. It's also equal to x plus 1 if x is bigger than 0. So this one, it has 2 domains. The first domain is for x less or equal to 0. So when x is 0, you substitute in the upper function, you get 0. So I have a point 0, 0 there. When x is -1, substitute in the very function, you get -1. So I have -1, -1, a point there. So this will be a straight line going down. Then starting from 0, not including it though, you take in the lower function, you get 0 plus 1, which is 1. The number we get here, 1, we don't include it because 0 is not included in this domain. Remember, to be included is to have such a thing. So now it's not included. Then we'll have, what about 1? So now f of 1 is equal to 1 plus 1, which is equal to 2. So we get 1, 2, a point there. So we can draw our graph in this manner. So just pick one more point just to know whether it's going up or it's going this direction. But a guide is that if the coefficient of x is positive, then it's going up. For this where x is to the power 1. If the coefficient of x is negative, then it will go down. Okay. They have also asked us to evaluate also what is f of -3. So you take -3 to the upper function because -3 is less than 0. So we'll get -3. And then they're also asking us to find f of 0, which we have found already, it is 0. You substitute in the top function where 0 is included. Okay, so we have another graph, the third one. F of x is equal to -1 if x is less or equal to -1. So 3x plus 2 if -1 is less than x and it is less than 1. So 7 minus 2x if x is greater or equal to 1. Okay, so again, we have 3 functions here. We have 3 functions. Before -1, there's a function. In between -1 and 1, there's a function. And after 1, there's a function. So let's start with the function that is before -1. It's telling us that f of x is -1 for every x less or equal to -1. So when x is -1, you also get -1. So you start from here to the closed point, -1, -1, and draw a straight line because it's a constant function for that interval. For all values of x less than -1, you always get -1 as a function. Now, in between -1 and 1, we have a different function. that is f of x is equal to 3x plus 2, provided that your x is between -1 and 1. So we just use 1. So what do we get at -1? Well, 3, -1 plus 2, which is -3 plus 2, which is -1. So we have the point -1, comma -1. So we're supposed to open here, but the area function closed this point. So we do nothing apart from having it closed. And then we also do 0 for 0 because 0 is in between -1 and 1. We also like 0 because it will tell us the y-intercept. It will tell us where the graph will catch the y-axis. So we'll have 3 multiplied by 0 plus 2, which is 2. And then we also get 1. 3 multiplied by 1 plus 2, this will be 5. Okay, so we get, it will cross, it will go all the way up to 5. There it will be open. So it's cutting all the way up to 5. So it means that I need to redraw my points. I want that point there to be 5. This one there, comma 1. And then also this side, I have a 5. So I did up there the 5. Okay, so I have 1, comma 5, where this one here is 2. So we'd also be interested in knowing what that point is. So you get the function 3x plus 2 and equate it to 0. And so for x. So x is -2/3. So -2/3. Then you move now to after 1. You go to another function. So f of x is equal to 7 minus 2x, provided that x is greater or equal to 1. That is, when x is 1 itself, you get 7 minus 2, which is 5. So at 5, this time around, you go there and close. Why are we closing? So we are closing because it's greater or equal to 1, so it's included. So you close and then look for a number that is bigger than 1, say 2, and see the value that comes out. So f of 2 is 7 minus 2 by 2, which is 7 minus 4, which is 3. 3 is less than 5. This means that the function is coming down. We can also know the value where it is crossing the x-axis by having 7 minus 2x is equal to 0. So 7 is equal to 2x. Divide by 2, divide by 2. So x is 7/2. So we have 7/2 there as the x-intercept. So we have our sketch drawn in that manner. So this is a straight line coming there with a point closed. So with a point closed, okay. And that's how you sketch such functions. So you take them as they are, each piece at a time. Each piece moves with its domain. So you don't rush the pieces and you don't cross. You cannot have a graph that can come this side, it comes and goes that side. No. Okay, the domains cannot enter each other. This graph cannot come go all the way up to there. No, you can't have two lines within the same region. So you find one line in each region, just like that. So the next questions are not telling us to sketch this. I need to try you. I give you a task and see if you're able to sketch. Sketch f of x is equal to -x minus 3 if x is less or equal to -3. and also 9 minus x squared if negative 3 is less than x, which is less or equal to positive 3, and also x minus 3 if x is greater or equal to, and if x is strictly greater than 3. If x is greater than 3. So try and see if you're able to sketch this function, and then I'll need the solution. So far, you have 4 questions. So you have, where are those questions? So you have 3 from here for finding the domains. You also have this one here for this domain. Okay. Question 6. Is it question 6? What am I doing? Oh, okay. So question 2. Given that is A, given that f of x is equal to 2x plus 3, and g of x is equal to 2 minus x squared. Okay, before we move, this question was also, we are also asked to find the value of f of, just noticed f of -2. So for -2, you go in the interval that is saying x less than or equal to -1, because -2 is less than -1. So that will be -1 just. Then f of 0, we found it. We said 3 by 0 plus 2 was giving us 2, because 0 is in between -1 and 1. Then f of 10 is bigger than 1, so you substitute in this equation, in the last equation, so that is 7 minus 20, which is -13. Okay, then f of x is equal to 2x plus 3, and also gx is equal to 2 minus x squared. So 1 is asking us to find f of g. Find f of g. Now by definition, you take g in f, meaning 2g plus 3. In f, where there is x, you take g. So we have 2 minus x squared plus 3, which is equal to 4 minus 2x squared plus 3, which is 7 minus 2x squared. That's the meaning there. And then 2, find g of f. So at this point, it is g, and then you take f inside. That is 2 minus f squared, which is 2 minus, what is f? F is 2x plus 3 squared. So you just need to expand this so that you can simplify. So we get, so here I'm multiplying 2x plus 3 by itself. That's what it means to square. You don't change signs. So you have 2 minus, keep the brackets so I don't confuse the signs. So I have 4x squared plus 6x plus 6x plus 9. That is 2 minus 4x squared minus, so now I'll say 6 plus 6 is 12, and then minus 9. This is giving us -7 minus 16. No, so I'm making a mistake there. I'm adding the variables. So, okay, let's add the negative variable, the squared one, -4x squared, and then minus 12x, then minus 7. So this is our composite function. Okay. Another piece, the third piece, is asking us to find f of f, but this time around when x is 4. So first, you can solve this function as f of 4, meaning you first get f of 4. F of 4 is 2 by 4 plus 3, giving us 8 plus 3, which is 11. Then take that 11 now, because we know what f of 4 is, it is 11. So we get f of 11 now. That is 2, 11 well is x plus 3. That's 22 plus 3, which is 25. Like that. Maybe we can go in the fourth one, where we get g of g by -3. Oh, so this is again g. In g, take -3. So you can pause it there, go to g and take -3. So you have 2 minus -3, well, there is x, but it is a square. So 2 minus 9, which is -7. So what we have g of -7. So that we get 2 minus -7 squared, which is 2 minus 49, which is -47. Like that. So the -7 inside there, don't need to be worried about the negative sign, because it will be squared. So it becomes positive and then 49, but the negative which is outside is not affected by the square. That's why it still lies there. Okay, then we have the fifth one, which is asking us to get f of g of -1. So we already have f of g. Remember, f of g is the first one that we got, 7 minus 2, where it's x squared, we replace -1 and have it squared. So this will be 7 minus 2 by 1, which is 7 minus 2, which is equal to 5. Like that. So they're very, very easy there. Nothing is complicated so far. Okay, so let's go to B and see what B has. B, for the functions f and g given, for the functions f, this is for 1, f is 4x minus 1, and g is 2 plus 3x. So what is f of g? So f of g here again will be, in f, we take g, that is g here minus 1. So that we have 4, 2 plus 3x minus 1. That is 8 plus 12x minus 1. So we get 8 minus 7, 8 minus 1, you get 7 plus 12x. Like that. And the next thing, we should also find g of f. Or just here, they are saying find f of g, g of f, and their domain. So let's find the domain of this. The domain of this is x. From this one, x can be any real number. Let's go to the inner function g. X also can be any real number. So it means that we close there. So again, here we get the intersection of the two domains. The outer, the final function and the function which is inside, meaning what you get here and what is inside the g. So let's see the second one. The second piece will get, okay, on the same, we are supposed to get g of f. of x, meaning g of f. That is, in G, you take f there. But you know what that f is? It is 4x minus 1. So you get 2 plus 12x minus 3. That is 12x minus 1. Then we get its domain. Again, if you look at the final solution, the domain is all real. Let's go to the inner, the f. Also, the domain is all real. So we end there. Okay, let's go to part B. I think this one will be nice. Part 2, f of x is equal to the root of 1 plus x. G of x is equal to, so G of x is equal to 1 plus x is equal to 1 plus x squared. So 1 plus x squared. And so what do we need to do? We must first get f of g. So f of g of x is, in f, we take g. That is root 1 plus g. But what is g? 1 plus 1 plus x squared. So it becomes 1 plus, it becomes 2 plus x squared inside the root. So now we want to get the domain. So say the domain is x such that from this one, 2 plus x squared should be greater or equal to 0. And the inner function, the g, x is any real number. Okay? Now the good news is that you've seen that this guy will always be positive for any value of x, because whatever you bring there, you square it first. That's when you add it to the positive 2. So meaning that it is also requiring just all real. So that becomes our domain. So what I mean there is that any value of x, negative 10, it will be 2 plus negative 10 squared. So it will be 2 plus 100, meaning 202. So the value will always be bigger than 0. So I found even the domain there. What if we switch them? It becomes g of f. Remember, I must also be finding g of f. If it becomes g of f, we mean in g, we take f. That is 1 plus plus f squared. That is 1 plus the root of 1 plus x squared, which is 1 plus x. That is 2 plus x. And the domain here for this part is all real. But for the f inside, it's 1 plus x greater or equal to 0, but x should be all real. So this part needs to be checked. 1 plus x greater or equal to 0. This happens also when x is greater or equal to negative 1. So it will be x, but x must be greater or equal to negative 1, and x should be in real number. That's how you obtain this very one. Okay. So that's the domain. So for the domain, you must be careful. You keep your eyes on the final solution. Keep your eyes on the inner function. Then combine the two domains. Okay, let's see. So this was question 2, part 2. We also have part 3, where f of x is given as 2 over x plus 4, and g of x is given as x minus 1. That is, we now need to find f of g of x, that is f of g, meaning 2 over g plus 4. This is giving us 2 over what is g? G is x minus 1, then plus 4. So we get 2x plus 3. Now x plus 3, this is our final function. So what will be the domain of the composite? It will be x such that x is not equal to -3 from this one. When you check the inner g, x can be any number there. The function is to be defined. So combined, we have the domain for the composite. If you want to get g of f of x, this is g of f, meaning in g, we take f, where it's x, but f is 2x plus 4 minus 1 over 1. I'm putting the over 1 to remind myself that I need to get a common denominator there. So I'll have 2 minus x plus 4, so that I get 2 minus x minus 4 over x plus 4. So we'll get negative x minus 2 over x plus 4. So the domain of the composite is x such that x is not equal to -4. Then we go and check for the inner function, the f. It has the same restriction, x is not equal to -4. So x should just be any other real number apart from -4. Okay, so I'm giving you part 4. Task. You have part 4. Part 6. And part 8 as an exercise. So part 7, I can't see the G there. And then part 6, an exercise, and part 4. Then part 5. Okay, so let me give you, so I've given you 4, 6, and 8. 4, where is 4? Okay, 4. No, 4 is just the same function there, so not 4. So 4, there's nothing there, just the same function. So I'll give you 5. Yeah. So you run from 5, 6, then 7 is not clear, then you get 8. So get that. So at our next class, we'll start from question 3. Okay. So let's move in this way. So you try this so that I can get to know if you have understood this tutorial sheet this far. Because the key thing in exam preparations, you need to know, one, have an understanding of the notes so that they help you understand the tutorial sheets. This is what comprises of the exam. The notes and the tutorial. If you understand your notes and the tutorial sheets, then you are sure that you're going to charge in the exam. Except there will be 1 or 2 questions which won't come direct from the notes of my tutorial sheet, but they'll just be like here, giving you f of x and g of x, asking you to get the composite. The only that they will change is to avoid giving you the exact things. Where there's g of x, then maybe they will put x minus 1 over x plus 7. But same composite, same domain. They ask you get the domain, get the composite, same things. And see, Temple sometimes he gets direct question from the tutorial sheets. Where he changes, you just change the numbers, but same language. So that's why it's very, very important to have all the tutorial solutions, understand them. Because if you understand the tutorial sheets, automatically you understand the notes. Because how can I solve the tutorial sheet if I don't know what the notes are? So understanding this helps us understand the notes. Understand the notes helps us understand the tutorial sheets. Okay, so we'll go to the class. I'll go 18.